So as I said, unfortunately, I do not have, I cannot use my other PC and because my webcam doesn't work there. And I do not have Visual Studio on my laptop. So this lesson, I cannot show you some examples on Visual Studio, but we will see some examples on the slides. And next week I will fix the program and we will see that. So my question is that did you install Visual Studio on your PC and Qt as well? Don't you have any problem with that? No? Okay. And any question from the last lesson? No? Okay, very good. And I should say, I mean, it's really important to check our Teams group because last year I was, I mean, in the previous years, I was using, I was creating a group in Esro organization for all the students. But this year, because all the lessons are online and we are giving the lesson through Teams, I decided to share the info of the class on Teams and also put all the materials on the website that I created for this course. So because I sometimes I get some emails from the students and they are asking about data or some other stuff. So don't worry, all of you are added in the Teams group, and if you check our group on Teams, you will see all the information. So but I'm not sure if all of you will check that. I think when I post something on Teams, you will receive an email on your email account. So yesterday I uploaded the data that you need. The data includes text files and also image files. You don't need to work with the images, just the text files. But since last year, the plan was, the project has been defined such that it could open also the image files besides the text files. So the data is coming from there. But you don't need to work with that. Okay. So this is the second lesson of our C++ course. And oh, this is not that fine. Of course, this is not that fine. 2020, this is from the last year. Lecture 2, okay, this is the one. So last time, in the last lesson, we discussed about what is C++, what is the relation between object-oriented programming and C++, and how can we have not how can, but what are the three elements of three principles of object-oriented programming. We wrote a small program in C++ through Visual Studio IDE. We learn how to debug our code, how to build and how to run our code. We learn how to work with variables, how to define a variable, constant, and enumerated constants. We said we have two different enumerated constants in plain enums and enum classes. And we said that it's better to use enum classes because they have some benefits more than what plain enums can give us. In this lesson, we are going to talk about expressions, if-else statement, the conditional operators, switch statement, functions, recursive function, loops, function parameters and arguments, and pointers. So most of the topics in this lesson are also easy concepts, except the pointer parts, but even in this lesson, we will not go to the difficult parts of pointer, and in the next lesson, we will discuss about that. But don't think that it will be like that in the next coming lessons. The course will get more difficult. But again, for your first part of the project, all the concepts are the easy concepts, but necessary concepts. All of them are the fundamental concepts that you should know if you are going to implement something in C++. And if you do your first project completely, then you can pass the course. But I think you are not here just to pass the course. And I hope you all can get very high scores. So expressions, we have 5 mathematical operators here, and like other languages, addition, subtraction, multiplication, division, and modulus. We should be careful in C++ that variables can underflow or overflow. In here, because we have different data types, it's really we should be really careful about that. But for example, in Python, we have an integer, we have we have actually not integer, we have number, we have strings, we have dictionaries like this. So the Python will increase the Python interpreter will increase the amounts of memory depending on the size of the data that you are storing in that memory. I'm trying to explain this in this way, but it's not what I'm saying is not 100% correct. But just since some of you may have experience with Python, I want to bold the difference between C++ here and Python, to know that don't consider that C++ is like Python and you should not be worried, because in Python when you are implementing something you are not worried about many different things, but in C++ it's not like that. But it's, to my idea, it's a benefit of C++, because then you can control your program and write it in a way that you think is the best. So we can add 2 variables like this and assign it to another variable. We can do something like this, and by doing this, the output of this expression will be in X and also in Y. So we can have multiple assignments like this in C++. Usually in the class, I ask the students to give me the answer for this, but I think you all know that. So if both of these operands are integers, then the division will be an integer division. So the output of this one will be 5. But if I put one of them like this as a floating point number, then the division here will be a floating division. So the answer would be 5 point something. We also have incrementing and decrementing in here. These are 3 different ways of incrementing our numbers. Integer number, for example, counter plus plus, counter equals counter plus 1, and counter plus equals 1. You can also do this expression for decrementing your variables. Give me the answer for this one. Let me see you. Sorry, into project feedback. Okay, I hope that we can have this lesson today. Don't know why I get such a strange error. So give me the answer for this one. What do you think? What will be the answer for A, B, and X here? Because I know some of you are already familiar with C++, and I think you know the answer. No answer?
I think plus plus x means that first is assigned and then x is added is incremented by 1. So I think a is 0 and then x is 2 because x is incremented 2 times, and b is assigned with x plus plus. So first x increments and then it is assigned to b, so b should be 2 as well, I think.
You got the point, but the thing that you're saying is vice versa. I mean, this one first increase the number and then assign, and this one will first assign and then increase, but you got the point. So as your friend said, but in the opposite way, so A and B will be 1 by this definition, and X will be 2. And I think you are familiar with this one, so I don't ask. Usually I put this one here because by any chance, maybe there is one student that is not familiar with the order of operators, mathematical operators. So this is just because of that rare students. So here with the priority is with multiplication, and then the addition will be run. So first we will have this one and that, and then this one. And if we want to do the addition first, we have to put parentheses around that. We have also relational operators: equals, not equals, greater than or equal to, less than or equal to. Logical operators are this one that will convert the results of these two expressions to binary and then do the and, or, and not on that binary number. If you are familiar with the priorities of your operators, you can write just an expression without having any parentheses, or so you can just follow the priorities of your operators and do the expressions. But the goal is to, in C++, when you are writing a program, I mean, in all the programming language, it should be like this. The goal is to write programs that work and that are easy to read and understand. Using parentheses helps to clarify your intent and avoid errors coming from misunderstanding operator precedence. So, for example, here, I know that this, my goal is to do the multiplication first and then do the addition. But and in some small expression, it's easy. It doesn't bring any ambiguity and so on. But in a long expression, it might be not really readable for the user of your code. Even for you, when you come back to your code after a couple of weeks or a couple of months, it might bring some ambiguity for you. So it's better to use parentheses, even if you don't, you know that you can follow the operator precedence. The first command that we are going to talk about, that it has a control flow. It has different blocks. Is if-else statement. So we have in if we have a parenthesis here, expression. If this one is true, this statement will be run, and if it is not true, then this statement will be run. And if we have multiple statements, we have to create a scope like this through two braces. Sorry. And put all the statements inside that block of code. I wrote here you should follow a consistent programming style. What does it mean? For example, here, all my braces are in a separate lines, like here and here. I should follow the same style for all of my files and for my project in all the other parts of the program. So for example, I don't like to see in one file or in the two different files of your program, your project, that somewhere you are using this style, you are putting the braces in separate lines, and in some other locations I will see, for example, the first one is here, the second one is here. So please follow a consistent programming style. I said this also when I was explaining the first part of your project in the first lesson. I gave you one table of the naming styles. Some of them were camel style, some of them were snake style. So it's really important, and it's actually depending on the company that you are working with. These naming styles will change, but we are in this lesson. I'm giving some style to you, but you can also have your own style. But it should be consistent, and I'm suggesting you to follow what I suggested to you, because for me it would be easier to read them, because I know that style, but it would be difficult for me to get familiar with your style and then read your code. The other thing that we have is conditional operator. So a conditional operator consists of 3 different expressions, and it returns a value. So if the expression 1 is true, the result of expression 2 will be returned. And if the expression 1 is false, the result of expression 3 will be returned. So what will be the output of this one? X is 1 and Y is 2. So the condition is false. Then the output would be Y, which is 2. The switch statement. This is something that is missing, for example, in Python. We have switch. We have it starts with the keyword switch. It has a block of code like this, which is defined with 2 braces. It has one expression, and we check if this expression equals to one or two of these cases. It should be matched only with one of these cases. But it can, okay, let's see what will happen. If the expression was equals to value 1, this statement, it can be a couple of statements, and it doesn't need 2 braces here. We do not need to do that. We can just write multiple statements here and one break keyword. That break is saying that, okay, after running this case, you should break the switch case, should go to the line after the switch. And if you do not write break, then it will go to the case 2 and it will run all the statements here until it will see break. It doesn't matter that it was not equal to it, it was not value 2. If we do not write break here and it equals to value 1, it will do both of these statements, and then when it sees break, it will break the switch case. And the default is like one case here, but it will be run only if none of these cases are true. So what is the output here? We have choice 2, and 2 is equals here to 2, and the output is 2. But since we do not have break here, it will go to default section and also write default here. So the break is really, the break statement is really important for the switch case. But it's only, a switch case is only for equality. It's not for checking if it is greater than something or something else. Okay, tell me what is wrong here. Actually, you can see the answer, but okay, to have some interactions with each other, it's good to answer this.
There is no break statement after do 0. So
Yeah.
do 0 and do 1 to 5 will be done.
Yeah, true. So as your friend said, there is no break here and it will fall through case 1 till case 5, because again, none of these things has a break statement here. And then this one will be run, and then we have break, then we will break this number. This is only the case if the user enters the number. So as you can see, to get it to get something from the input, we should use cn. It's td cn again, but it's these operators are in different direction, in the opposite direction of what we have for stdcout. You need to use such a statement when you are writing your project and when you are asking the user to enter its comment. So in that project, you will have one while. So your program will have one while in your main function, and it will receive some commands from the user, and you will process in that while those commands. So you see here, while I'm teaching the course, I'm giving you some hints for your project, and you should keep all this in your mind while you are writing your program. So to get something from the input in C++, we have seen from the user. I mean, it can. Okay, I wanted to give you some more information, but I think then it will be confusing to you. So just to know, to summarize, to get something from the user scene, to show something to the user, you use cout, and both of them should have a std. So your first exercise is this one. You should define an enumeration constants for different types of error. So you will have an enumeration constants. Each side that you have no error, you have, for example, wrong input parameters, and so on. Just try to come up with just some different types of error for yourself. It's just some imaginary error types. Initialize a variable by a value of your enum, which should be, for example, when you are initializing that, it should be successful or no error. So that one of the errors of your enumeration constant should be no error, because when we start the program, there is no error in your variable. Then implement a switch case to show an error message for each type of the error. So your expression in switch case is the variable that you have here, which is of type your enumeration constant. And the cases should be different values, different constants of your enumeration constant. It will check the equality between them, and it will show some errors. tdcout will be your command in your cases. Inside one of the cases of your switch case, you should define and initialize an integer variable and print the value. Then, I mean, this is the actually the main question for this exercise, and I didn't give you the answer, but I think it's not really difficult to find the answer for this one. We will see such an example in the next slides, in the coming slides, but you will not see the answer for this one. Last year, I was giving these exercises in the class and people was doing that in the class, but my experience from the 2 or 3 lessons, online lessons that we have last year when the corona came, it is really difficult to have such a thing in online classes. For those classes, I ask, even for those online classes, I ask the students to do some things on their own PCs, and I ask them to share their screens with me. I got some controls. We were at that time we were working with Skype for giving the lessons, but it was really difficult. It was really time consuming. We couldn't manage the course till into 10 lessons, and we had to have the lessons more than that. We had to, I think we had the 12 lesson or 13 lesson for the C++ code just because of those difficult online lessons, and we were not really get used to that. So, but this year, because we having only online lessons, I cannot follow that way of teaching. But I ask you to do this exercise at home on your PC, run it, and in the next lesson, I will come and show you the answer and explain all the benefits, what is the best way to do that, and some hints about that exercise. Okay, for example, for this exercise, we do not have many hints, but for some exercise, we will have different way of different solutions, and I will give you different solution, and I will give you what is the drawback of this solution and so on. So it's really important to do this exercise. Last year in the class, I could force the students to do that in front of me, and I was checking all of the students, but this year I can't do that, but please do it yourself at home. So what is a function? A function is a subprogram that can act on data and return a value. You are familiar with main function, which was the first function that you have in your C++. The main function is, we said that the main function is defined in global scope. And if you remember, I showed you in Visual Studio that upper part of the main, if you define something in the upper part, you can see all of them here on your main because they are defined in global scope of your program. Okay, so the functions can be defined in global scope, then we will call them global function, or can be defined in local scopes. For example, we can define a namespace and define that function inside that namespace. Or we can define a class and define a function inside that class. So we call those functions the local function of those scopes, the local function to that namespace, the local function to that class, because we have defined them in another scope. But we should not really go for global functions. Since we are not familiar with classes, we still work with global functions in our examples. But you should not do it for your project. When you have classes, when you have namespace, and you have a bigger project, you are familiar with different things, you should not do that. The usage for global functions are very rare, and even in those cases, you can put them in at least in a namespace. When a program calls a function, here you see we have 4 different functions, and we are calling those functions in the main function. When a program calls a function, execution switches to the function and then resumes at the line after the function call. So for example, here we have a statement. It can be a couple of statements here. Then we call this function. The compiler will go here, run it from here till the end. When it see, not till the end, when it till the time that it will see return. When it returns, or if it doesn't see the return, till it will go till the end of your function. It's written, it will come here and it will run the other statement. So this, it will switches, the execution will switches to the function. If you remember when I was telling you how to debug your code, I said that, okay, we run our code with F5 in Visual Studio. I'm talking about how to debug your code in Visual Studio. We press F5, it will see one breakpoint here, and then imagine we put one breakpoint here, and then if I press F10, I can run my code line by line. But what does it mean? If I press F10 here, it will go to it will stay here. Then if I press one F10, it will go here. So it will not go inside your function when you want to debug your code. You have two ways. You can put one breakpoint here inside your function, then press F5, and by pressing F5, it will jump into the function. Or you can just press F11, and F11 will go enter your function, and there you can press F10 to run your program line by line. You may think that, okay, we are learning these short keys for Visual Studio. What would happen if I want to use, for example, PyCharm here or other IDEs? Recently, most IDEs are supporting the keyboard, the short keys from other IDEs. For example, I myself, since I'm familiar with Visual Studio, now I want to work with PyCharm. I can go into its setting and I can change the short keys to the short key of Visual Studio. By default, there is an option that I can change, and I can say that, okay, I want to use the short keys that's available on Visual Studio for my PyCharm. So then I don't need to use different short keys. I don't need to memorize different short keys for my when I'm going to debug my code. But it's not possible everywhere. Sometimes you are going to debug your code in Linux, and it's not, and you are not going to use IDEs. Then you cannot use these short keys, and you can use other short keys. So, well-designed function perform a single, specific, and easily understood task identified by the function name. Complicated tasks should be broken down into multiple functions, and then each can be called in turn. So you should not have very large function. It should show that it's doing one task that its name is showing to us, and it should not be also very small or very big. So you should know what you are doing. So just the rule is that it should do what its name says. So how can we define a function? A function has a name, a return type. The return type can be void, and it means that it doesn't return anything. And if we want to write a return here for void, then we do not need to write any expression in front. We should not write any expression in front of return. We just write return semicolon. And but if it has some type here, it should return a value. We have parentheses, and inside that parentheses, we have parameters. So these are just some variables. These are some just local variables to this function, these variables are defined here, and they will be gone after this one. And also, if you define some variables here, those variables also define inside this scope, and after this scope, we will lose those variables. Let me see. Yes, I can explain. Okay. Something that I should tell you is that in Python, sorry, in C++, you can have multiple functions with the same name, but with some constraints. But you cannot have such a thing in, for example, in Python. Okay. So in C++, I can have two functions or more with the same name only if their parameters, the number of parameters that they have, or the data types of their parameters are different from each other. What does it mean? It means that in C++, the function's signature is their name and their parameters. So the number of parameters and the type of the parameters plus their name is the signature of our function. And when we are defining function, that signature should be different from each other. So if their name is similar and their data types of their parameters are different from each other, or the number of parameters that they have are different from each other, we still have different function signatures. And we can define such functions in our program. Compiler reads your code from top to the bottom. Calling a function before its definition leads to a compiler error. So, for example, if I define two functions in my global scope in my main.cpp above main function, and if I call the second function in the first function, then I will have one compiler error because I defined the second function after the first one, and I'm calling the second one before it gets defined. So the order matters in C++ because the compiler is going from top to down. It's also the case with other languages. What is the solution? I can reorder my functions. I know that I want to call a second function in my first function, so I reorder them. But what will happen if I want also call function 2 in function function 1 in function 2? So there is no order here. So the solution is using forward declarations. What is forward declaration? It means that, okay, we have this is my function definition. We can have function declarations. What is a function declaration? This one. It only says to the compiler that I will define in the coming lines of code a function with this signature, with these parameters, with this return type, and with this name. So if I write function 1 here, and then function 2, I call inside function 1, function 2, I said that I will have problem. But if before this function 1, I just write the function declaration for the second function, then the function 1 is aware of that second function, even if the second function is defined after that, because it has seen the function declaration of the second function. So this function declaration should come before before calling the functions. This is, I said that we do not define our function in the global area. Okay, usually it's like that. Usually we have a class. Inside that class, we have a class, and for that class we have a header file, we have a CPP file. Actually, today I wanted to show you some examples of how you can create header file and CPP file, but I will show you in the next lesson. Since I do not have Visual Studio here, and you cannot run the program there. So I was saying that usually it's like that. We have a class, and for that class we have one header file and one CPP file. Inside that header file, we put our declaration. Inside that CPP file, we put our definition. Even for one function, we can do such a thing. So in one function, we can put the declaration of our header files in we can put the declaration of our functions in one header file, and we can also define that function, put its definition in a CPP file. That header file and CPP file should have the same name. It's not compulsory, but you should follow this style. And then you will include that header file inside your CPP file, such that your CPP file knows that function declaration. And when you are going to use that function, you only need to include that header file. I should really show you in one example. This is a bit difficult to, I am not sure you are getting what I'm saying, but in the next lesson, I will show you the examples. So this, you should know only that if you are going to define some function, you have one function declaration and one function definition. And to be able to call them, you should first put their function declaration before calling them. And to implement such an idea, I will show you one examples in the next lesson. So what is overloading? If you go for an interview, in most companies, they usually ask you, I mean, one simple question that they ask is that, okay, what is overloading? So the answer is that when we have two functions with the same name but different parameters, then it means that we have function overloading. These two are not really good examples of function overloading because we have numbers here for our parameters, even if it's even if they are showing the overloading concept, but they are not a good example of that because the parameters are different data types, but both of them are numbers, and they can be casted to each other. They can be converted to each other, and this may show you some warnings when you are building your program. And as a programmer, you should know that you should solve all the warnings, because warnings are the potential errors, potential bugs for your, not errors, potential bugs for your program in the future. So this is just something that I wanted, because with the current data structure that you are familiar with, that I mean, with the things that you are, you know, I couldn't give you a better example, at least to my mind. I couldn't give you a better example, but what is doing here? So I'm get sum 1, 2, and 3, and I have get some with floating numbers. For this one, it should call this, and for this one, it should call this one. But first of all, this one is returning an integer here. So it means that it's doing it has to do a conversion to be able to return an int here, because the output of here is a float, and it will show you one warning and because of that. We can, and I should also say that when I call this one, it will show you one warning, and it says that, okay, I mean, probably even if this one will go for inside this one, because it can because the data can be converted. But if you put, for example, here float, you are saying that no, it should call this overloading function. But again, I should repeat that it's not a really good example of overloading. For example, you can, instead of this in your project definition, I was saying that you will have some commands that that are comparing if in your select function you had, for example, age in two braces, int, and quotation marks, and one value inside that quotation marks. And I was saying that, okay, it's similar to that. It's the select is saying that give me all the list of files in which the age is bigger than, for example, 20. And I'm saying that the conversions should be int, okay? So I can define one solution is that to define overloading, to overload this comparison. But again, this is not the best solution for this project. The best solution is using two templates. But I want to show that, to let you know that one answer can be this: to overload function to do the comparison for different data types. So even if it's int or it's a string, the comparison is the same, because relational operator are the same for all the different data types. But the function should get different data types. So you can define multiple function with the same, even with the same body. But let me think what would be a good example. The good example for overloading, which is really useful for us, is that we have two functions that are doing similar tasks, but their body is different. They have to implement it in different ways to do the same task. Okay, so for different data types, for example, I'm going to construct a class. Okay, I can overload the constructors of my class. And so the task is the same. I'm constructing a class, okay? But from different data, the input can be a file, the data extracted from a file, or it can be, for example, from just some numbers. It means that I can construct that class in two different ways, but the task is similar. So the name of the function should be similar. But the body, the way that I can implement, that I have to implement that task for different data types is different from each other. So I will have two different functions with with different data types, different parameters, with different bodies, but the task is similar. I can give you one hint now, but we will discuss about that later when I'm teaching a template. In templates, the body is also the same. Okay, like here, the body is the same. The way that I'm implementing the task is the same. Then the task itself is the same. the body, the way that I implement that task is the same, only the data types are different. In that case, I will go for template, which is the case for your project. The body is the same, the task is the same, but the data has the input parameters are from different data types. We will discuss about these things more when we are explaining templates for you. What is default parameters? So default parameters this is our function declaration. We are saying that it has 3 different parameters. Output this parameter. If I want to call this function, I should call this function such that my function, and I should pass 3 different arguments to this function. But if I put equals to 0 or equals to anything, any number here in my function declarations, then when I'm calling my function, I can just pass 2 arguments, and the default argument, the default value for this parameter will be assigned to this parameter 3. I can also pass 1 argument for this parameter, but if I don't pass, the default parameter will be assigned to this parameter. If I want to have a default parameter, a default value for this parameter, I should also define a default value for these 2 others. So it's coming from right to left, that all of them should have default values if I want to have a default value for the one at the left side. Local variable versus global variables. A local variable is a variable which defines in a local scope. I discussed about that already. I said that if you define something inside a function, inside the scope, it is local to that scope, and after that, it will be lost because those variable has been defined in stack memory, and this is the one property of a stack memory, that it will be gone. Sorry. So here I said that this parameter is defined in this function, and it's local to this function, and we will lose it after this function. So if I call this function, this variable will be created. I can have access to this parameter inside the function, and after that I don't have it, it's gone. What about the variables that defines here? I can define a variable here, and I have access to this variable inside that. But in C++, you can define just a local scope with 2 braces. So by just writing this here, I'm creating another scope here. What is happening here? So x is 0, x is 20, and here, when I'm accessing to x, the rule is that it should see the 1, it should consider, okay, till here, nothing happens. Inside this local scope, I still can see x. Okay, and I'm assigning this x to 20, and I can output this, which is 20. But since it's another local scope here, I can define another variable with the same name, and this one is local to this scope. But this one is different from this. They are in different location of stacked memories. And if I set x1, this one can see the closest one. So the closest one to this is 1. I will see 1 here. After this one is gone. I can only see this x here. And when I print this x, it will show me 20. But if I do not write these braces here, and if I only have these lines here, I will have a compiler error, because I'm defining two variables with the same name here. This is against what we have in Python. In Python, if you remember, we have, if you are familiar with that, we can, actually there we do not have data type, but we are defining, we are setting two name for two different objects in one block of codes. But here, the variable definition is different from just assigning a variable and value to that variable. So if you think that, if you are familiar with Python, don't confuse them with each other. Confuse it with C++. Python is an object program. Everything there is a object. But in C++, it's not really like that. It's different. We have objects, of course, but this one is not an object. This is just a variable. First, we define it, then we can assign some values to that. But in one scope, we can just define it once. If you want to have in this scope two variables with the same name, by its appearance, but in fact, it's not like that. You should define another scope. So in one scope, you can have just one variable with the same name. In C++, global variables, global functions are legal, but they are almost never used because global variables are like shared data. What does it mean? For example, inside the global scope of one header file, I will define a variable. Then I will include that header file into some other header files and CPP file. And by doing that, the code of that header file is copying to other files. But also it means that from the other files, I can have access to that variable since it has been defined in the global scope. Okay, now you want to debug your code. You can't keep track of the changes is done actually on your global variables because every file can make a change on that. Every control flow of your program can change that. And it's really difficult. Every code structure can change that. Different scope can change that. So if you want to find the bug, you cannot really find it. It would be difficult for you to track all these changes that is applying to that global variable. So it's not really good to use that. What is a recursive function? We have, I think you in mathematics, or if you have data structure, I don't know, You are familiar with, I think also discrete mathematics, you also learn about recursive functions. Like in factorial is a series of some elements, and it can be write like a recursive function like this one. If it's n is 0, it's 1, otherwise is n and n minus 1 factorial. How can we write this one in C++? We can refine factorial int n. If n is 0, return 1, else return like exactly what we can see here. Else return n factorial n minus 1. So if it's n, for example, 0, it just return 1. But if it is n2, it will return first n, which is 2, times factorial 1, and it will come here. It will, by doing this, it will call the factorial function with the by passing 1 to n, and then again it will call 1 factorial 0, and then it will give return us 1, and it will come back, compute all the values from the down to the top to compute factorial 2. You can use such a structure for reading all your text files from different folders and subfolders. So you will have such an expression. If it is a file, you just read that. You do your task. And your task would be creating one object for that file, which is a data package. So you will read the name of the file, using the parameters, using the data available on the name of the file. You will construct an object of your class representing that file, and if it is a folder, you will call that function again like this one and create your structure. So this is one thing that you can use in your program. Actually, there are many good libraries that can read files from your folders, but I suggest you to implement it yourself to get familiar with recursive functions. Tell me what is wrong here.
The function myfunc has a void, so nothing as a return parameter, a return value. But then 3 lines below, y is assigned, an unsigned short is assigned to the return value of myfunc.
Yeah, a very fast answer. Very good. Yeah, you are right, because here we are saying that the function has should not return anything, and but here I'm returning something, so it will gives us a compiler error, and it's not correct. Let's see if I have other. Okay. So we got familiar with if statements, we got familiar with functions, global scope, local scopes. Now we are going to know how can we define some loops in our program. We have while, we have for. How can we define while loop? Here, we have two different ways of defining a while loop. We have either while or do while. For while, which is more common, first we initialize our counter. It's not a condition, it's counter, sorry. We initialize the counter to 0. It can be anything else, but for my plan, I mean, for this example, it's 0. And I'm checking if the counter is lesser than 10, then I will, in the body of the loop, I will add it by something, I will increment it by 1. So I can add it by, for example, by 5, or by the step size can be different. And the body here is just showing the counter. It can be anything else. So it has initialization, checking the condition, and one body. And inside the body, the counter should be increment or decrement, depending if your counter is increasing or decreasing. What about do while? In do while, the body of the while will at least be run once. We have that initialization like this one, counter in the body, we add it by 1, incremented, and then we will test the condition. The difference here that we have semicolon, but for this one we do not have semicolon. What will happen here? Can you guess? I think you can. I'm talking about this.
The counter will increment until 5, and then it will stop because then the counter isn't smaller than 5 anymore.
No, the problem is just this semicolon here. As I just said, for this do while, we put one semicolon here, but for while like this, we do not put that semicolon. So it means that it doesn't have any body. So the counter plus plus here is just one statement after while scope. And it will stop here and it will be an infinite loop. But these are not, I mean, these are just simple questions, but you may see something happen in your program as a bug and you think that, okay, what happened to my program? Did I implement it correctly? Why it's working like that? You should, but I mean, by your experience when you are debugging your code, after a while you got familiar with your mistakes and all the things that can happen. And when you are debugging your code, you will go directly to those possible potential errors. But I'm giving you just some hints that which errors can happen when you have a bug. So what is continue, breaks, and return? So here it's just a while loop. I'm saying that if counter equals 5, continue. What does it mean? I run the loop for counter 1, 2, 3. Sorry, for 0, 1, 2, 3 till it reaches 5. But if I see 5, I say that, okay, don't run the body for the rest of the body of the loop for this counter and go to the next. But the problem is that this implementation is not correct. Why? Because I'm saying that, okay, if you see 5, then continue. I'm not increasing counter here. So, okay, it will not run this one, but it will not increase counter. So it will come here, 5 is equal, lesser than 10. Yes, it's less than 10, less than 10. Counter equals 5. Yes, it's 5. Okay, go again. So it will be an infinite loop that is checking these two conditions multiple times because counter is not increasing. What can I do? I can put here counter plus plus. So, but again, this one is not correct. Counter is 0. it will come here. Counter is equals, if it's not equal, does not equal 5, it will show that counter 0. Okay, counter is still 0 for the next run, so it will show us 0 for infinite times. So, so what is the correct answer? If you have continue, you should write your increment section, increment statement here, counter plus plus. If counter equals 5, continue. So because it means that I increase that. So if I go there, it's not 5 anymore. So for what about I didn't say break. Okay, apparently I didn't give any example of that. Okay, for break, or maybe in 4 I gave you some examples. No, I don't know why. Okay, I will explain it here. If I just told you that continue is saying to the compiler that do not run the next statements in the scope for this current counter and go to the next step. Break is saying that go stop running the loop and go to the next statement after the loop. What does return do here? Return will return you to the function or place that is calling that loop. That is calling the scope containing that loop. It's better saying like that. For example, you have here a while, and this while has been defined inside a function. And inside your main function, you are calling that function. If I write return here, it will stop running the loop and it will stop running the function and it will come back to the main. So all the statements coming after that return, no matter it's inside the while or inside other functions, just because it's inside the function that while is defined there, that while where while is defined, return, none of them will be run, and return will force your compiler to come back to the function calling that function. So we are familiar with continue, break, and return. We also have throw that is not really good to be used, but there are some libraries that are using that. In some rare conditions, you may also need to use that. But what does it do? I will give you some example with throw, but throw is not just returning to another function, to the function calling that. It will crash your program, or if you catch that exception, like what you have in Python, if you catch that exception, then it will come back to where that exception has been catched. We will see some example, but these are continue, breaks, returns, and throws are some statements that will change the control flow of your program. Because we said that the compiler starts from top to down, but with break, continue, and throws, we can change these things. Okay, for loop. For loop is also similar to, it's very common, even more common than while we have initialization, test, and action. This is one example. In the initialization, I initialize one variable, but this variable is local to the scope of for, unlike what I had for while. For while here, the variable has to be defined before the while scope, and after this while, I still have access to counter because it has been defined in this outer scope. But here, for, the variable has been defined here, and after this scope, it will be lost and I don't have access to this counter anymore. Here, I have one statement which returns true or false. And it's, for example, here it's checking if it is lesser than 10. I will increment I by 1 here, and I'm showing the results. Initialization. Initialize a counting variable. Test is the condition. It should be an expression that returns true or false. Action, increment or decrement of value. I just said the answer for this one. What is the output for this one? Just look at this, not the rest.
Since the condition is true for the first few times, because there is no initialization, it only checks the condition each time. So the counter, which is outside of the for loop scope, increments
this one.
each iteration until counter equals 5, and then it stops.
Yes, because you can either write the counter, because we just said that counter, we have access to this variable here, but I mean, even if I don't write, for example, if here I'm defining this counter outside the loop, okay, but even if it was here, I could write the counter plus here. This is just a way that I can write for like while loop. So it's the correct statement. It will do exactly like if I write int counter here and counter plus here. But I want to let you know that, okay, as long as we have one condition here which says that it's true, it's still a for loop. Even if I don't write anything here, like what you can see here, it's a for loop, but here it's an infinite for loop. And it doesn't have even any body, so it's still one statement, and it's a valid statement in C++. What about this one?
I have a little question about the one just before. So because you said that the variable is local, if we would, after the for loop, if you would print the counter, will it still say 0 or will it say 5?
For this example, it's not local because it has been defined before loop in the scope containing for and containing this variable as well. But if int was, if this statement was here, then after this, we cannot access this counter. So if I, for example, if I put this one, just here. What happened? Yeah. Okay. if I just put this one here and here, if I try to access that, like what you said, we can print that counter. It will give me a build error. It will give me a compile error. You cannot even compile your code because it says that there is no counter here. You have not defined any variable with this name because after this scope, you don't have counter. But since it was outside the loop, before the loop, it is defined in this scope, and after this, it's not gone, it is still here. So I can access to that.
Okay, thank you.
You're welcome. What's your answer for this one? Just this line.
I think it is an infinite loop.
Great. You got familiar now with that semicolon from the previous example. But as you can see, if I do not write, oh no, it's not infinite loop. Yeah, because it has a body. It would be an infinite loop only if I do not write, for example, this one here. Because this one has still I0 till I mean, it has a condition. In the example you saw for while, it had a condition and it didn't have the counter. But for this example, you have the counter here, even if it's printing that I, it's also incrementing that I. Okay, so it has all the things that a for loop needs. It has the initialization, it has the condition, it has also the incrementing thing. So this means that the for is correct. It's not really common to write such a thing. We usually put this one in the body of the loop, but it can run. And what about here? What is the answer for this one? Just imagine that I said to you that this statement should return true or false. It doesn't matter that it's a relational operator or not. The thing that is matter is that it should return true or false. But now answer this one.
So I think when n becomes 0, that will be seen as false, and then the loop stops.
Yeah, correct. So it doesn't matter if it is a relational operator, a relational expression, or conditional expression. It doesn't really matter. Okay, of course, it's more common to have a relational expression here in a for loop, but it can be something similar to this because we know that the integer numbers can be converted to Boolean numbers. And if it is 0, it's false, otherwise it's true. So as long as it can do that, it's correct, it's a correct loop. And what is wrong here? Only in this one, not this.
The counter starts greater than 10. So the first while condition is false. So it will directly skip the loop and never even try the code.
Yeah, and it is wrong because we can see from the body that the plan was to incrementing that, but it is wrong. It should be like greater than 10. Otherwise, okay, it can be, I mean, the condition can be false. It's not, we put the condition here to make sure that while will be run only if the condition is true. But based on the body, we can guess that the plan was not to be like this based on this body and also this value. Okay, give me the answer for this one.
there is a semicolon after the 4, so you won't go to the next. You won't go to what you thought was the body.
Yeah, exactly. It is an infinite loop now. So in this example, we had incrementing thing. I mean, the action that we needed to increment the function, the counter. We have the condition. We have also the variable initialization step. But here we have all of them. We have also the body. Let's try this then. It should be an infinite loop, but no, it's not. Again, it's these. I hate this semicolon, but again, even while teaching this course is annoying me. So it should not be an infinite loop, but we can check that. But it's as you said, it will not go to the body. It will just go to the end of the loop, and it doesn't show anything. So that's the problem with that. So we always, when we see a semicolon, we always guess that it's probably an infinite loop. I mean, our first guess is this one, but then when we check the statement, we will say that no, it might not be like that. But again, when there is a semicolon after a for, or a while, not a do while, there is a problem there. So the problem, we don't know what is the result of that unless we check the code. But if we just see a semicolon there, we can guess that there is a problem. But for do while, it's part of the statement. It's not a problem. So I have some exercises for you here again, and you need to do this at home. First, you will write a program in C++ to find the series of this one. If you just check the internet, you can find the answer. There is no score for your these exercises, but try to do them for yourself. So it's not really good to just Google them. I will give you the answers in the next lesson. We will discuss about all the answers, but try to do it for yourself to practice more. Get a list of sorted number and the value. Check if the value is among the list. If so, return its position. So to define a list of variable, the plain structure that we can have is just an array that we do not use really often in C++. It's more a C style way of coding. So we have an array like this, and we can define it like initialize it with this one like this. And to access every element of the array, we can just write the name of that with these indices. Okay. But try to see how can you implement this one? How can you find the position of a value in a list which is a sorted list? Write a program which receives two variables of the same type, checks if they are equal or not. Consider the following type: int and std string. I haven't taught you std string, but it's just like a string in your program. It's coming from a STL library, but it's not really a complicated thing. So, and I actually give you the answer to this one while I was talking about overloading. But give me at least two solutions. How can you implement such a program that can do this equality for this one? In fact, it has three different solutions at least, but you should give me at least two solutions. And not me, because I'm not going to check your exercises, but in the last, for yourself, do it for yourself, but I will give you the solution in the next lessons. Function parameters and arguments. So we have function, when I was explaining how to define a function, I told you that these are the function parameter, and when we are calling them, these are function arguments. These names are interchangeably used, but okay, we can call them like this. Okay, I said to you that we should use forward declaration. This is one example of the forward declaration that you can see. This is the forward, this is the function declaration, and this is the function definition. Actually, we have seen also such an example. But I didn't point it out at that time. Let me show that example to you. Okay, here you can see this is the forward declaration. Okay, it was wrong because I was returning something while the function doesn't return anything. Okay, but the structure is correct. I'm defining the function here, but I'm calling this function inside main before its definition. So we have forward declaration here where we put our function declaration, and we are saying to the compiler the definition of this one will become later. Okay, so this is a way of forward declaration. We can also put this one inside a header file and put this one inside a CPP file and include that header file here. Then it acts exactly like what we have here. The example will be given to you in the next lesson. This is a function. This is local to that. We can call this function like this. We can either put just one value or a variable +1 or anything, if an expression that is returning a number. Also for here, we can also we can call it pass the argument by just some values like this. So passing, now I'm going to discuss about how to pass the arguments to the parameters. The first one is pass by value, which is what you just saw. It's just either a value or an expression that is returning a value. Arguments are never changed by the function being called, which prevents side effects. So it means that here you see this, it's just int x, int y, int x, int x. So inside this, what is happening? Okay, let me explain what is happening. If I here write my find 6, 6 will be passed to here. A variable int x will be created here. It will be initialized by 6, and it will be lost after this scope because int x is local to this function. And it will not change anything because we just send some value to that function. Or if I put just here x, not even x plus 1, the value inside x is using to initialize this x. This x is different from this x. This x is an int variable. It could be y or anything else that define where this function is getting called. But this x is defining where the function is defining. This is for the function. So if I call by value, this x, which has been defined outside the function, will not be changed because it's just called by value. So this prevents side effects. We don't worry about what will happen to our variables that we are passing to the function because we know that that function will not change that variable because we are passing them by value. But the problem is that it will copy the data. So here the value of x, which is in our stack memory, will be copied to another part of the stack memory to create this variable inside the function. So we have one copy here. Copying structs and classes can incur a significant performance penalty, especially if the function is called many times. Imagine you have a recursive function. Either calling that recursive function will create some, will get some memory from stack memory, and calling those variable that is defining inside that recursive function is getting memory from the stack memory, and you are copying the data multiple times. So we are calling that function multiple times. This is not only for recursive function, but it's very common for recursive function. Or inside the loop, you are calling that a function multiple times. So whenever you are calling a function, even one time, if it is a struct or a class, because they are usually large data for us, it's not really good to pass them by value because you will copy all the data into your function, into your stack memory again and again. So when can we pass the arguments by value? When passing fundamental data types and enumerator, and the function does not need to change that arguments. So if you do not want to change that arguments, and it's just a fundamental data types or enumerators, just pass it by value. But when shouldn't we use when shouldn't we use passing the arguments by value? It's when passing structs and classes. So even, I mean, we will learn about std vectors, std strings, and the rest in the coming lessons, and they are coming from STL library, which is a standard template-based library. We should not use call by value because they are also some template classes. They are also some big data. So it's not really good to use call by value. Remember this when you are implementing your project. What is call by reference? This is another way of passing arguments. What is a reference? First, we should know what is a reference, then we will discuss how to pass arguments by reference. A reference is just another name for your variable. So I can here define a variable in integer by this statement. Here I'm defining a reference variable. Is a reference variable, which is initialized by this variable, not by its value, by its variable itself. Both of them are just some variables in our stack memory, but both of them are in the same location. We have one location of memory in a stack, but we have two names for that. And if I change either I, either j, both of them will be changed. So passing by reference, for passing by reference here, I'm giving you one example. One of the exercises that you had was to write a function, enumerated constant like this one that you can have actually part of the answer here with this example. and I ask you to write a function with a switch case that shows one message, that returns a message or shows a message for every of these constants. So in this example, I have one enumerated constant here. You are familiar with it. I'm defining a function like this, and inside here, instead of having just a regular variable, I'm defining a reference. It's very similar or exactly similar to a variable, a regular variable, but it's saying that you if you pass a variable to this function, A will be just a name for that variable. And it doesn't mean that it will copy the data. No copy will happen here. And if I change A, it will change the variable that is calling that is passing to that. So imagine this one and this line of code. If I here create an integer variable, int value 5, with +1 value, I'm passing value to this. Here, a reference variable will be created by value. A and value both are referring to the same location of memory in stack memory. I will change A. Since it's in the same location of memory, it will change also value. So in case it's a fundamental data type or any other data types, but you want to change it inside the function, you should pass it by reference. I'm writing a function here and instead of having reference here, only this ampersand here, we also have const. What does it mean? It's saying that, okay, create a reference, but make it const. Don't change this one. What does it mean? Let's see how I can call this one. It gets 2 floating points and 1 error. I'm creating a variable imp 10, and a constant variable, enumerated constant variable here with this one. This is some part of your answer for your first exercise. And I'm calling compute vision with imp, and error. For imp, I'm saying that, okay, pass imp to A or to this function by reference, but don't change that. It should be a const. So if it is a struct or other things, other large data sets, it's not a fundamental data type, and you don't want to change it, so you can send them const by reference. You can pass them const by reference, because we said that for them, we don't send them by, we don't pass them by value, because if we do that, it will copy the data. But for this one, I'm just I'm using call by reference, because I want to change this value here. But why I should do this? Why I should have why I should change this one here while I can return it here? Because in C++, I can only return one value from my function. But sometimes, like this one, I want to have 2 output from my function, or more than that. In that case, the second or third or the other outputs of my function should be just some reference variables of that function, like this one. So what is happening here? This is really a good function. I'm saying that, okay, divide A by B and return this one if B is not 0, otherwise put error, assign error to a one error wrong input data and then return 0. So when I'm calling this function, the pattern is this. The pattern is saying that I call this function, the result is auto, but I will use the result only if there is no error, only if this function will not return an error for me. So if I check first, if error is no error, then it's std, I will print the results, otherwise I will handle the error. Okay, how can I handle the error? It depends on your program. If it is a GUI, probably you will show a message to the user, or if it is a console application, you will show a message on your console. But how can I no, but how I can have a consistent message for an error type? Because usually the plan is like this. I mean, in C++ or any other languages, it's really important to handle the error. Okay, there are different ways of error handling. As you can see here, we have 3 ways. The first one is just returning integer or boolean values, and based on that, for example, you call a function, it should do a task for you, and if it returns true, it means that it was successful. If it returns false, it means that it was not successful. But it's not really common to use such a thing, but it's for handling your whole program. The other way is throwing exceptions that I will give you an example later. But again, throwing exceptions are really dangerous because you may not catch that and it may bring up some problem for you, especially if you have multiple threads for your program. And the other way is the one that you can see here. We define an enumeration constant and a function to translate it to the corresponding message. This is your first exercise. And whenever I'm writing a function, that function should return an error for myself, I mean, not returning, just should change the error based on what happened in that function. And when I'm calling that function, I should check if there is an error, if an error happened in that function or not. And for handling the error, I should use a function that will translate that enumerated constant to a sensible message to the user, because you are not going to show just some enumerated constant to the user, because it's not really good things. They are not familiar with this thing. You should show them some, interact better with your user and show some message to them. I will explain this slides, and for the other parts we do not have enough time, and in the next lesson I will discuss about the other way of passing arguments. Here I want to say that depending on the compiler, some of these things may return error to you or not. It really depends on your compiler, because here compute imp error. I'm calling first of all, I don't need to return anything. It's correct for all the compilers, so I can just call a function, even if it returns something, I do not need to use that return value somewhere. But it's not really common, but it can do something like this. Or I can write it like this one. As you can see, I'm using const reference here, but here I'm assigning that references by some values. Since it's const reference, usually in most compilers it's correct, but for some compilers it is not const here, and I'm just passing some values to them. Some compilers may return error and they ask you for some variables. Also here, so in some compiler, both of them are correct for this one, but in some compiler, they are not correct because this is not const reference, it's just a reference and it asks for a variable. But it depends on really on your compiler, but you should know these things. Okay, if there is any question, you can ask. Otherwise, we can stop the lesson here. No question? How many students are in the class now? How can we see? Oh, I think there is gallery here. Gallery, large gallery doesn't show me. Together mode. No.
You can see it when you click on the icon with the two stick figures.
This one?
Yeah.
Oh, okay. 15. Good. Okay, for these lessons are not really difficult, but it's like more I'm adjusting, I'm tuning, I'm giving some hints about even if they are simple structures, I'm giving you some hints to say that, okay, this way of implementing is better. It's better to, and I'm also trying to give you some hints for your project definition, but in the second half of the C++ this course, it will be more difficult than this. So if you have any question, you can ask. No question? No? Okay. Have a nice day, everybody.
Until next week.
Bye. Okay, let's stop recording.